Hello everyone, this is Mr. Ahmed Faidi من Artificial Language School. Today, inshallah, we'll talk about new video in geometry, and now we'll talk about applications on vectors, part 2, physical applications. So we have first definition, the resultant force. So we have the force is a vector passes through a given point and acts along straight line. The force is represented by a directed line segment and it's drawn by a suitable drawing scale. So we have an example. If we have force of magnitude F1 equal 10 newtons and we want to represent this force as a vector. So we have magnitude and direction. So we will take E is the direction of the east direction. So we take the direction is E. Then we have 10 newtons, so we can represent each 5 newtons by 1 centimeter. So we can represent the directed line segment of length 2 centimeter to represent the force 10 newton. So it's read as F1 equal 10 E. We have another example. If we have force of magnitude 15 newtons towards west direction, so we have F2 equal negative 15E because we have west direction in opposite direction of east direction. So we'll take the force with negative sign, so will be negative 15E. And F2 is represented by directed line segment of length 3 centimeter because we take each 5 Newton represented by 1 centimeter. So if we have 15 newtons, so will be represented by 3 centimeter in west direction. So F2 equal negative 15E. We have an activity, force of magnitude 6 Newton acts in the east direction on a wooden cube. We choose that each 3 newtons can be represented by a drawn directed line segment of length 1 centimeter. So we have 6 newtons, so we'll need to represent it by 2 centimeters. So what is the length of the vector which represented this force? Will be 2 centimeters. If we have additional force of magnitude 3 newtons, we have additional force of 3 newtons acts in the east direction of the cube. What is the magnitude of the force acting on the cube now? So we have 6 plus 3 will be 9 Newton. So what is the length of the directed line segment which represented this force on the drawing? So the length of directed line segment represented this force on the drawing will be 3 centimeter because we have each 3 Newton represented by 1 centimeter and we have 9 newtons now, so 9 newtons will be represented by 3 centimeter. When you try to move a book on a horizontal surface of rough bench, so you may feel resistance of bench surface to move the book, which is known as a friction force. So the friction force is the opposite force to the motion. If you move the book on the surface of bench, which if the two forces is bigger, the force of acting to move, the force acting to move the book or the friction force. So we have two forces. We have impetus force and friction force, and the greater one will make the book move or still as it. So we have here a new definition, resultant force. Resultant force, the forces acting on an object are subjected to the process of adding vectors. The result of this operation is known as the resultant forces acting on the object, where F equal F1 plus F2 and so on. So to find the resultant force acting on the wooden cube, we have here wooden cube and we have two forces acting on this wooden cube in the east direction. So we have F1 equal 6E and F2 equal 3E. So if we want to find the resultant force, so F equal F1 plus F2, which is equal to 6E plus 3E, which is equal to 9E. So the resultant force acting on the wooden cube equal 9E. And we have here another example. To find the resultant force acting on the book when we try to move it by a force F1 of magnitude 5 Newton and magnitude of the friction force 3 Newton. So we have the vector E, or we consider the vector E in the direction, or the unit vector in the direction of the book movement. So we have here F1 equal 5E and F2, which is the friction force, equal negative 3E, because 3 the friction force in the opposite direction of E. So we have F1 equal 5E and F2 equal negative 3E, the friction force. So the acting force on the book will be 5 minus 3, so will be 2E. So it means we have 2 newtons acts in the direction of movement of the book. We have another example. Find the resultant force F acting on each of the following. So in the first one, we can take the unit vector E in the direction of 40 kilogram. So we have here the resultant force will be 40 E minus 30 E, so will be 10 E. So it means we have the resultant force is 10 kilogram weight in the direction of movement, and E is the unit vector in the direction of the force 40 kilogram weight. In example B, we can take the unit vector E in the direction of any force, so we'll take in the direction of the 70 Newton. So the resultant force F will be 70 in direction of E minus 70 in direction of E, so will be 0 vector or O vector, because we have the two forces are equal but one of them in the opposite direction. Now we will take the unit vector E in the direction of 100 kilogram weight, so the resultant force will be 100 E minus 50 E, so will be 50 E, where E is the unit vector in the direction of the force 100 kilogram weight. And the last one we have here the unit vector E in the direction of movement of 15 kilogram weight, the force 15 kilogram weight. So we have here the resultant force equal 15 in direction of E plus 15 E minus 30 E, so will be 0 or the O vector, where E is the unit vector in the direction of the force 15 kilogram weight.